Welcome back. In the last video, we learned how to name cyclic alkanes or cycloalkanes, but there's one type of cyclic molecule that scares a lot of students and has slightly different IUPAC rules. So I want to dedicate an entire video to these molecules. This is a bicyclic molecule. The name makes sense, so you can kind of see that this is two cycloalkanes fused together. Some of the carbons on this bicyclic molecule are especially important, such as the two carbons highlighted. You can imagine the chains that connect the two highlighted carbons as bridges, and the highlighted carbons as bridgeheads. A useful strategy to naming bicyclic molecules is to organize the molecule so that the longest bridges are outward. For this molecule, we have two carbon bridges and one carbon bridge. I'm going to redraw this molecule so that the two carbon bridges are on the outside and the one carbon bridge is on the inside. To name this molecule, we first have to count how many carbons we have part of the molecule. Including the bridgeheads and the carbons of the bridge, we have 7 total carbons. To number the molecule, we need a number going toward the longest bridges first. Therefore, we number in the direction of either of the two outside bridges first and then the inside bridge. This is why organizing the molecule this way is helpful. We should also pay attention to the substituents on the bicyclic molecule. On carbon 7, we have 2 chlorine substituents. Now we put this all together. Bicyclic molecules are named starting with the substituents, so 7,7-dichloro. We then use brackets to indicate the lengths of the bridges, separated by periods and organized longest to shortest. 2, 2, 1. Finally, we end with the prefix bicyclo and the name that corresponds with the total number of carbons. The full name should be 7,7-dichloro-2,2,1 bicycloheptane. Remember that you need to pay attention to the lengths of the bridges first. Even if you can give a substituent a lower number, you need to number in the direction of the longest bridge. However, if we have 2 equal length bridges, and one has a substituent, like the example below, number toward the bridge that gives the lowest number. Although naming these molecules may seem difficult, it'll become repetitive after continuous practice. Trust me, I was a student of organic chemistry too. Try the practice worksheets we have linked below and watch our explainer videos to get a better grasp over these concepts. In the next video, we're going to go over naming alkenes, alkynes, as well as cycloalkenes and cycloalkynes.